Good day, students. So last time we focused on understanding integers, right? We try to understand the absolute value, the number line of the integers. We also try to compare and order integers. So that is actually our new lesson in the new chapter of our lesson in grade 7. This time, we will be focusing on the properties of real numbers. So as we all know, in the new chapter, we are dealing with the real number, real numbers. So let's try to understand first before we move on the operation. Now let's try to understand first the properties of real numbers. So properties of real numbers. So when we say properties of real numbers, these are very useful in performing the operations. Although we don't have yet the operations on integers. Now, but we will discuss this one first because this matters most also. Okay, so in simplifying algebraic expression. So these properties are assumed to be true statements without any proof. So even without a proof, it is already obvious that this is correct. So that is the meaning of properties. Okay? So let A, B, and C are real number. That means let's assume that A, B, and C are numbers that are real numbers. Real numbers, we will have a separate discussion on what are the different real numbers. This time, you can interpret that one as those that are decimals, the one that you learned before, fractions. Okay, those are real numbers. Okay, and then the numbers, the integers, those are also part of real numbers. So let's start the different properties of real numbers. We start with the closure property. We also have the commutative property, associative property, distributive property of multiplication, identity property, inverse property, and the multiplicative property of zero. Or we call this, there is also another name for that later. Let's start with the closure property of addition. So when we say closure property of addition, these are the examples of closure property of addition. That means that if the sum of two real number is a unique real number. So when you add a particular real number, for example, an integer plus an integer, the result is an integer, just like this. If we add fraction to another fraction, the result is a fraction as well. Remember that a whole number is a fractions also. So we consider whole numbers as fractions. Okay? Although under that, separate gapon ang name ng whole number under the fraction, under whole numbers. Okay? Letter C, that is also an example of decimal. Okay? So that's it. No? The sum of the decimal, still, it is a unique decimal or real number. If it's not a decimal, it's a unique real number. Part of the real number still. Okay? And we know if we add real decimal and decimal, although sometimes the answer is whole number, but still whole number is part of the real numbers. Okay? That means A plus B is a unique real number. Next is closure property of multiplication. So closure property of addition, if we have addition, we also have multiplication. That means if we multiply a number or any real numbers, the answer is a unique real number still. So we call that one as closure property of real number. Also, that is this symbol, no? So A times B is a unique real number. Okay? Next, number 3, commutative property of addition. So when you say commutative class, always remember, you can try to interpret it this way so that you can easily memorize the words. Okay? Commutative, it is just like in a jeepney. Commute. You try to commute and then, di ba, sometimes you try to change places. So that is also the meaning of commutative property. You change places. Okay? That means if we have 13 plus 7, we know that 13 plus 7 is equal to 20. So even though we try to change the places of 13 and 7, we say 7 plus 13 now, the answer will still be the same. And you know, of course, that the answer is still the same, right? So definitely, this is also true. So without any proof, this is true. Okay? So this property states that the order of the addends does not affect the sum. So even if you how you make the order, still your answer will be the same. And we can verify it from there, from the examples given. No, we try to verify it and it's correct. So the examples of this one, so any number A, any real number B, so A plus B, it's still the same with B plus A. Okay, whatever is your A and whatever is your B. Next, the same with multiplication because we are dealing with factors in the multiplication. So the same thing, if we multiply 9 times 7, it's equal to 63. The same thing also, the same result also will happen if you change the order to 7 times 9. And you can see that from the example. So this property states that the order of the factors does not affect the product. Okay? So A times B equals B times A. By the way, if you have letters like this, I hope you are done with this when you were in elementary. We are done with the basic algebra, that we are no longer using the multiplication symbol in high school. If we will be dealing already with variables just like that, or letters that represents a number, if you combine them together just like this, A, and on the side of that is B, that means you are dealing with multiplication. Okay, that it means it's A times B. Okay, although we usually read that one as AB is equals to BA. Now, as we go along with algebra na. Okay. Associative property of addition, that means association. Associative means association. If it is association, it is a group of people, right? So the same thing with the associative property. It is a group of numbers. So when we say group, we are dealing with parentheses. I hope you understand before the lesson about GEMDAS, which we are dealing with G. That means groupings. So that means you are dealing with parentheses just like that one. So it's 3 plus 4 plus 5 is equal to 3 plus 4 plus 5. So even if you change the groupings there, the inside, what is inside the parentheses, you change the what is inside the parentheses, still your answer is still the same. Okay? And we can verify it from there. Same with letter B and same with letter C. So the definition of associative property is that the property states that the grouping of the addends does not affect the sum. Remember that if we talk about commutative, that means changing the order, changing the seats, for example. Associative property, changing the groupings. Okay? So it is the group that we change. Okay? Not really changing, but we change the places of the numbers. Okay? So for example, A plus B plus C is the same with A plus B as a group and then plus C, as you can see there. Associative property of multiplication, the same thing. It's associative. We are dealing with parentheses. Okay, and still the same. It's just that we are dealing with factors because we are talking about multiplication. Next is distributive property of multiplication over addition or subtraction. Or you can just simply say DPMA or just the distributive property in a word. That's okay. That's enough for me. Okay? So when we say distributive property, class, that means you will have to distribute down and you can have the same result. For example, so by the way, again, if you are dealing with parentheses 3 and then parentheses 4 or close parentheses, that means it's multiplication. Okay? So in high school, most likely we are dealing with parentheses na, and that means it's multiplication. If there is no operation in between, just like this, no operation in between 3 and 4, that means it's multiplication. If we are enclosing 4 inside the parentheses, if we enclose it with parentheses. Okay, so here, that means 3 times 4 times 5. So we have to distribute that one. So we start with 3 times 4 and then 3 times 5. And let's see if we have same result, no? So we have 3 there, 4 plus 5, it's 9. And then 3 times 4, it's 12. 3 times 5, it's 15. Let's see if we have the same answer. Yes, we have the same answer. So, distributive property states that for any numbers A, B, and C, if we try to distribute now the one factor to the sum or the difference, then we have the same answer now. And it looks like that one. Okay? So that we call that one as distributive property of multiplication over addition or subtraction. Next is identity property of addition or additive identity. So when we say additive identity class, you are dealing with addition, and from the word identity, your identity will reveal. So it's still the same. No, it's an error. So if it's a identity, means error. Means your identity has revealed. It's the same thing. Okay? For example, this one. What are you going to add something to a number so that your answer will still be the same? Of course, 0, right? So it's still A. So we call that one as additive identity. Okay? So it is the sum of any number and 0, and then the result, it's still the same. Okay? The number itself lang gihapon. Same with the product. But you don't have to multiply it with 0. You multiply it to 1 so that your answer is the same. So A times 1, still the same. B times 1, still the same. 1 times 1, still the same. 3 times 1, it's still 3. Okay, 25 times 1, it's still 25. 1 times the decimal 0.75, still the same. Okay, the number itself. Okay, so that's it. And then the last one is the inverse property of addition. Oh, this is not the last one, sorry. So inverse property class, what from the word inverse, it's the opposite of it. So what do you mean by opposite? So if you are dealing with addition, what is the opposite of a positive number? It's a negative number. And it should be the same number still. So a positive letter, that means a positive variable, also the same letter A. Okay, so that means now the answer for that is 0. It is 0 because they have the same distance. Okay, the answer now for that one, it's the 0. Later, when we discuss operations on integers, you will understand why the answer is 0. So as of this time, so you have to have it in mind that if we add a positive and a negative, the same number siya, the answer is 0. That is for the additive inverse. How about if we are dealing with multiplicative inverse? Still, we are dealing with inverse, but we are dealing now with multiplication. So, what do you call that? How are we going to do that? You have to do the reciprocal. Diba the opposite of a particular number is the reciprocal of it? Or a fraction is the reciprocal of it? For example, A. As we all know, what is the fraction if it's a whole number? By the way, if it's a variable class, now it's only letter A, most likely it's also a whole number. Okay? So A, there's a denominator 1, automatic. Okay? I hope that is clear. And what is the opposite of that, or what is the reciprocal of that fraction? The reciprocal now is 1 minus 1 over A. Okay? And then the answer daw on that one, it's equal to 1. Okay, remember, for example, let's have a fraction. Here. This one. 5, 7 times 7, 5. Remember when you were in elementary, you have what we call cancellation method. So you can cancel 7, the top and the bottom, cancel 5, top and bottom. The answer is nothing, right? Nothing is left. The answer is nothing. As I have said before in our first day of class, anything in math now, anything that we cannot see, it's equals to 1. So since we cannot see anything there, that is already 1. Again, the answer is 1. Again, remember in the additive inverse, the answer is 0. The opposite of it, it's a negative number. But here in the multiplicative inverse, the answer is 1. So always remember that one, because there are cases in your activity, I'm not going to discuss that one really. You will have to do the formative. So you just have to figure out, since I already discussed naman the different properties. So no worries, because we will be dealing with that we will be discussing with that one again. But recap na lang, only the formative assessment that we're going to discuss, not this one already. I hope that is clear for everyone. So the product of any given, and then the last one is the 0 or the multiplicative property of 0, or we call this one as 0 property. Okay? So when that means that if we multiply 0 to a particular number, the answer is 0. So 0 times 13, it's 0. 0 times 1/4, it's 0. So 0 din na siya, class. Anything that we multiply to 0, it's 0. Okay? Let's have the practice exercise, and we will do that one during your face-to-face encounter with me. Goodbye, and God bless us all.